Welcome back again. This is the M340 BMXNOR RTUconf Tool demonstration, part 3. I am demonstrating the creation of a simple but typical RTU application for tank level monitoring with trending and alarming using a MODICON M340 and DNP3 protocol. In parts 1 and 2, I created and loaded the M340 Unity code and the BMXNOR DNP3 module RTUconf.xml file. I used the U2V DFB Mngr to create the Unity Pro code and variables for the M340, and I used the M340 BMXNOR RTUconf tool to create and configure the BMXNOR DNP3 point database in the RTUconf.xml file. In part 2, I leveraged features of the DNP3 protocol that will minimize the bandwidth usage of the communications between Vijeo Citect and the M340 RTU in the target system architecture. So now I have a running M340 RTU, ready for Vijeo Citect to communicate with it via DNP3. In this final part, I will be creating the Vijeo Citect project, applying additional configuration settings to minimize the bandwidth usage, and demonstrating the working system. To save time, I have already created a new Vijeo Citect project and added a user, so now I'm ready to create the servers and configure the DNPR driver that will communicate with the M340 RTU. I will launch the U2V Bldr and use the DNPR server builder utility. In this demo, I did not create an RTU project list file in the RTUconf tool, so I will cancel selection of that file, select the Vijeo Citect project, and I will manually add the RTU to the list for auto-generation of my servers. Here I define the IP address of the Vijeo Citect server, my computer, and then with a right click in the DNPR devices pane, I add the RTU. I generate the servers. Here you see the results. With the RTU using UDP, there are additional files created in the target Vijeo Citect project. Details regarding these files will be provided in another video demonstration. Next, I use the builder to generate the variables, alarms, and trends. I select the exported Unity Pro project file, then the Vijeo Citect project, then the RTU associated with the Unity Pro project file, and then the associated RTU XML file. I give the alarm area a descriptive name, and it's possible for me to change the configuration of the DNP points that will be generated into the Vijeo Citect application. I process tags. Unity variable comments can be 1024 characters, and Vijeo Citect variable comments only 48, so I have some that are too long. I can review these and truncate if the result will be acceptable. The builder finds that the RTU DNPR tags do not exist. A list of the tags that will be added is provided, and then the tags can be added. The new alarm and trend variables are discovered and provided in the GUI for review. Then these can be generated. With generation done, the Vijeo Citect project can be updated. In the background, I created a Vijeo Citect page, and here it is. The level transmitter is graphically represented here as a genie, and it has been linked to the M340 level transmitter DFB by only these 3 fields. The page properties have an on-page entry event that forces an integrity poll of the M340 RTU. There is also a button on the page to allow the data to be refreshed. It also forces an integrity poll. There are two other buttons. Strictly for testing and demo purposes, these allow me to enable and disable the report by exception in the M340 BMXNOR module. There is also a display of the amount of time remaining before the next scheduled integrity poll. Finally, the ellipse has fill animation that is linked to the level transmitter value. Before I test the working system, I will first show you the DNPR driver configuration that has been set up in the Citect INI file. This is where the polling control is defined. With these settings, the polling of the M340 will only occur every 11 minutes, so bandwidth usage has been very minimized. Now I will test the system. In the background again, I have packed and compiled the Vijeo Citect project. Then I ran the computer setup wizard, as this was a new Vijeo Citect project. So now it is ready to run. But first, let's take a look at what's been going on in the running M340. The sine wave generator has been cycling the level transmitter signal up and down for quite some time, and there are many events captured in the BMXNOR analog event buffer. Here you can see that there are over 2,500 events. Now I will run the Vijeo Citect project. What you will see is that even though the M340 will not get polled during the remaining time of this demonstration, the level transmitter data will be updated every time the level changes 4 feet, and alarms will be processed whenever they occur. Normally, the level in the tank will not change 4 feet every 24 seconds as it is here, because of the settings in the sine wave generator. Before I log in, let's take a look at the event buffers. The DNP protocol is doing its job, and the events are being reported. The first thing to note is 2 alarms in different alarm categories, identifiable by different font colors. Secondly, note that the level data updates every 4 feet and the poll end time in seconds value. Now I will enter set points for the alarm thresholds. You will see the alarm banner displayed alarms font change to the non-active unacknowledged font as the alarm conditions clear. The unacknowledged alarm font maintains the same color but is non-bold font. I will bounce over into Unity and show you the level transmitter DFB and its data. I see that I need to enter the set points for the rate of change alarm. I will set it for 1 foot in 1 second. Now I will slow down and dampen the sine wave before taking a look at the level trend data. I will open a pop-up of the Process Analyst. And I will add a pin for my tank level transmitter. The level transmitter trend shows the sine wave, and there are 5 data points in this graph, peak to peak, every 2 minutes. Expanding the trend time window shows that the DNP3 protocol magic has backfilled the trend graph with the M340 data collected over the time that it has taken me to create this demo. Looks like that took 4 hours or more. I will play with the Process Analyst for a moment and move on. In this view, the change that I made to dampen and slow down the sine wave can be seen. Next, I will take a quick look at the unacknowledged alarms. Here are all of the alarms that have occurred since I started Vijeo Citect. The alarm category differentiation is by color, and since they are all non-bold font, none are active. So when I acknowledge the page, they all go away. This concludes this demonstration, and now I will provide a quick wrap-up. I began with a Unity Pro project only containing a configuration. I used the U2V DFB Mngr to create code for the M340 CPU, and then used the M340 BMXNOR RTUconf Tool to create the M340 DNP3 database for the BMXNOR module. Then I used the U2V VJC Bldr to create the servers and load all variables, alarms, and trends into the Vijeo Citect project. I created a graphics page and put the system online. The DNP3 protocol worked magic by backfilling 4+ hours of data recorded in the M340 RTU while I created this demo. As always, thanks for your interest and time. Subscribe to this channel to see more demonstrations of Unity Pro tools, tips, and tricks.